Okay, today we are focusing on using AI models behind the scenes to fuzzy match and identify inconsistent organization names in data files and data sets, such as a CSV file, as a simple example. And sometimes this is called entity resolution. So, inconsistent data, such as variations in the spelling of an organization or a company name, can lead to significant challenges in data management and analysis. It complicates the process of merging data sets together, it reduces the accuracy of analytics, causes discrepancies in reporting and business intelligence analysis, which of course can lead to misguided decisions, and nobody wants that. So here are some examples of what you might run into. You can see some different variations of HSBC Bank, different ways that it might be spelled or represented in a database. Apple Computer, IBM, International Business Machines, Bank of America, Kaiser, 7-Eleven, GE, Geico. I'm sure you've run into these kinds of inconsistent organization name representation in data sets many times. And so, how can this issue be addressed? Well, let's start with a simple two-column database. And essentially, this is just a CSV file of two columns where you've got a company name, Best Western, Samsung, so forth in the first column, and then the second column is a descriptive category, what type of business that it is. Again, a simple example, but these CSV files or text files, TSV files, JSON, whatever the case may be, of course, can be very complex. But in this example, just two columns. And so what we want to do is discover if there are any duplicate company names to contend with. And what that means are we want to find similar company or organization names that might have different spellings, variations, perhaps they're acronyms, or possess different organizational words such as Inc. or Corp, or maybe include a .com on the end. Whatever the case may be to cause them to be represented differently, even though they are likely the same company or organization. So the way we're going to do this in this case is to algorithmically generate a similarity key using AI models, specialized algorithms for this specific type of data, knowledge bases, and some behind the scenes machine learning to make this happen. So to give an example of what some of these similarity keys might look like, here you can see on the left some company names: Telstra, ShopRite, South Africa, Snowflake, Microsoft. If you look, the company names on the left, even though there's variations, they generate the same similarity key on the right. So the idea is that this similarity key, which is nothing more than a text string which can be stored or used in a lot of different ways, represents, we're going to generate it algorithmically, and it's a canonical key essentially that represents hundreds, if not thousands, of potential variations of an organization name. We will then match these entities based on those that share the same similarity key rather than matching on the actual data itself. And therefore, that will be how we overcome the inherent inconsistencies in the data. So fortunately, Interzoid does all of this for us. And we can analyze a CSV file, in this case, using Interzoid's browser-based matching wizard to see the process in action. So here I'm at the wizard, which is at wizard.interzoid.com, as you can see. And now generally what you would do is go to interzoid.com and you can get an API key and you can analyze your own data. In this case, we're just using a sample test file, so an API key is not necessary. So we're just going to create a new matching job, and here is where we enter our data source. So for example, there's all kinds of SQL types of database connections we could be analyzing, but in this case, we're just going to be using a CSV file. And then we have to choose the category of matching. Since we have company names, we're going to choose the company name set of algorithms, different algorithms for individual names, for example, addresses, etc. And we could use a file URL, meaning that the file is accessible on the web, perhaps an AWS S3, a shared Google Drive, whatever the case may be, or a local file that we browse for. But in this case, we are just going to try the sample report, which is available on the web. And all we have to do is enter the match column number. So this is the column we're going to generate the similarity key for. I click next. There's some other options, but we're not going to worry about those now. I'm going to generate a match report so we can actually see the matches. The other option, of course, would be just to generate a similarity key for every single record in the file, which is what we're doing in the match report anyways. We just won't show the ones that don't match. You would do the similarity keys only, for example, if you're merging across or matching across data sets or searching, or one of the different ways that you might want to be taking advantage of that similarity key. The return type is, in this case, we're just going to return text, but you could be returning JSON if this is part of a pipeline. And by the way, the whole thing is accessible as an API as well. If you go to the website, you can find that. Maybe you want to return it as HTML if you're showing it in a browser. In this case, we're just going to return text. I click next. I get some details here, the file type, the location, the line count. This job will consume 93 credits. However, it won't be against our account because we're not using an API key, and this is a sample file. And then all we have to do is click run. And here are our results. It's just telling us that this is a sample file. And you can then see it went through that file. And if you check the URL of that file, you would see that these different variations are in there. And it found Costco and Costco stores, SDSU, San Diego State, Goodyear, 7-Eleven. And if you see, or if you look here, the reason why it found these match clusters is because these different organization names in the first column shared that same similarity key. And that's the reason that it essentially sorted and then displayed those records that shared the same similarity key. Now, of course, you can generate similarity keys for multiple columns. You can store them, use additional columns as part of the match. You can get very complex or just stay simple with how you make use of that similarity key. The idea being is this helps us really overcome all of the different inconsistencies that you know typically a computer can't understand or find. And because we're using AI models behind the scenes, as well as sophisticated algorithms that understand the nuances of these different types of data variations you might run into, it's all happening lightning fast in a multi-threaded parallel processing system. You can do some pretty powerful things with these similarity keys. Again, the idea is to leverage AI, which, by the way, also helps overcome inconsistencies in international data, all types of different organization names that you might want to be, or that might exist in the data that you're analyzing. And then we can download these results. There's all kinds of different things that we could do, but just wanted to give you a flavor of how matching works using these similarity keys that are generated algorithmically behind the scenes from Interzoid. And of course, this can all be accessible or accessed via API, as well as using this wizard through a myriad of different types of data sources and targets and so forth. So if you want to give it a try, head over to interzoid.com and get an API key, and you can get the trial and start analyzing your own data and hopefully eliminate to the greatest extent possible the challenges you have with data management as a result of inconsistent, redundant, and duplicate data. And this is, some people will call this fuzzy matching, others entity resolution. But whatever you want to call it, at the end of the day, the idea is to have much better quality of data to work with so that everything that you do with that data is more effective and with a more valuable and with a greater ROI. Better data, of course, is the goal. Thanks. That's it. We'll see you over at Interzoid.